let me try to share my screen. So, so indeed, I was asked to say a few words about Francoise because she finished her career here in Helsinki. Actually, when did she move to Helsinki? It's difficult to say because she was moving so fast around the world. But during during the years 2013 and 2017, Francoise was Finland Distinguished Professor. This was a program funded by the Academy of Finland and our technology agency, with which we could hire part-time professors from abroad. But quickly first, a few words about the life of Francoise. She was born in 1952 in Mulhouse, France, where she also made her master studies. She graduated in Mulhouse 1974 and left to the University of Toronto, where she got her PhD in 1979. After two years postdoc in the same university in genetics, she moved to Xerox Research Center in Canada, where she spent a long time from 1981 to 1993. According to my experience, and at least in my country, this long, over 10 years, service in industry would be totally the end of any academic career. But not in Francoise's case. I checked from SciFinder that during these years she published 71 research papers, which is enough which is as much as some professors published during their career. After Xerox, Francoise then went to academia. She started as an associate professor in McMaster University, Montreal, in Canada, where she was up to 2000. In 2000, she took a professorship in University of Montreal. In Montreal, she retired 2018. I must say that I myself, I have not known Francoise for her whole life. Many people in the audience have certainly known her longer. I met her first time in 1998 on a conference in Japan. Invited her immediately to Helsinki as an examiner of one PhD, which she did, and after good discussions in Japan and in Helsinki, she became then a bit later a docent in my university in 2001. And as I said, 2013 to 17, she was this part-time professor in Helsinki. But same time, since 2011, she also served as a principal investigator in Tsukuba, in International Center for Materials, Nanoarchitectonics. So when she came to Helsinki, she came either from east or from the west and continued to the other direction. After retirement in Montreal, and when this part-time professorship ended, she continued as a full professor up to 2020 when she retired also here. An important part of her activities was, of course, ACS journal Langmo. She served also this journal enormously long time, since 2001, first as a senior editor, then as an executive editor, and finally as editor-in-chief. So she did a lot, but maybe some words about things that Andre is also here. I forgot I had this photograph about life in Helsinki. Here we have just finalized one PhD defense where Andre was the examiner. After seeing this photograph, Francoise concluded she's a midget. Cannot comment that. But most people know that Francoise very actively studied a phenomenon called co-non-solvency. And this paper was published in 1990, which was during the Xerox period, when Francoise and her collaborators observed that polynipalm, which dissolves well in water as well as in methanol, loses its solubility in some certain mixtures of methanol and water. Here we see the first published phase diagram. This was a phenomenon that Francoise studied actually through her career, and even here in Helsinki, she supervised the PhD work of Fabian Puch, where they, for example, they studied 3 different polyoxazolines, where, as you can see here, the 3 different substituents here. And interestingly, only this green one, where the propyl group is free to rotate, it shows this co-non-solvency effect. It is interesting because in the case of polynipalm, often people say that this phenomenon might be somehow related to the solvent structure around the proton in this position here. In polyoxazoline, we don't have this proton, and it seems that the flexibility of the substituent plays indeed an important role in the behavior of this polymer. In 1990, Francoise also published a paper on fluorescence studies of aqueous solutions of polynipalm. So, and just a few years later, 93, review on the photophysics of pyrenes. This review has been cited enormously many times. And Francoise indeed showed it clearly already in these early works how pyrene can be used to investigate well, we can, from a spectra of pyrene, we can make conclusions concerning the polarity of its surroundings. Sure, also information on this can be also received through measuring the lifetime of the excited state, and the excimer emission also tells about the associations in these solutions. So certainly Francoise was very well known of her fluorescence studies. One topic, when I was thinking what were really the topics that Francoise liked to work with and worked a lot with, one topic was polysaccharides, various polysaccharides, and actually especially of the nanogels built of those. Here I took an example of work which Francoise conducted with her Japanese colleagues, Morimoto-san and Akiyoshi-san. They also visited here in Helsinki, as far as I can remember. And this is Well, this is one work, and another work which I also very often tell about this in my lectures was about pullula or cholesterol pullulan nanogels, which also contain poly and isopropyl amide. So these nanogels, they are interesting, of course, as such, the properties, and certainly they are very good candidates for carriers, drug carriers in controlled drug release. Topic which I do not know actually at all, but where Francoise was also very active, is quantum dots. And I feel that, well, I always felt that it's very natural she's interested in this, because these are strongly fluorescent compounds or systems. And so for a person oriented as Francoise was, it was quite natural to go into quantum dots. The question of the toxicity of those is important, and this is an example of a review or mini review on the cytotoxicity of quantum dots. Now we are coming to 2010, and years later. This photo was taken in Moscow in 2016. We were on a polyelectrolyte conference in Moscow State University. So the photograph is taken, and this Leninsky Gori city of Moscow is somewhere far, far away there. 2015, Francoise, together with Ari Halperin and Matti Kröger, published an exhaustive review on poly and isopropyl amide phase diagrams. I wanted to take this because Francoise was so very well known also on her studies on polynipalm. And this this review, here are just some of the numerous figures of this in this paper. This review is interesting, and it explains what they discuss in detail various reasons for the so many published different looking phase diagrams for polynipalm. They discuss molecular weight distribution, N group, staticity, and so on and so on. Really interesting reading. And one of her very recent papers was also on polynipalm. And this is a paper that we here in Helsinki, we discussed quite a lot. How Ren was synthesized several of the substances studied here and conducted many of the experiments. So, so this team observed that in some cases where the mobility of polynipalm is somehow restricted, the phase transition may take place in 2 steps, as we see in this blue thermogram. This was extremely interesting for me, because we here in Helsinki, we had observed earlier similar phenomenon when we prepared gold nanoparticles grafted with polynipalm. So on this polynipalm shell, which covers the gold surface, the polymer segments close to the surface, they show the transition at lower temperature. The surface part at higher temperatures. Well, as Sergei said in the beginning, Francoise gave, in our previous meetings, he gave a talk about azopyridine and the use of azopyridine. And azopyridine, this paper was actually the last one that Francoise published. A paper on azopyridine with which one can turn polynipalm, sensitize polynipalm also to not only to light, as in the case of azobenzene, but also to pH. Also, it's noteworthy that this is a hydrogen bond acceptor, whereas this one is donor. I know that Francoise was working with a review on core non-solvency. This would be an excellent addition to her list of publications, but she didn't have time to finalize this. So I hope I could, in these few minutes, somehow give an idea of some of the interests of Francoise, whom we will all seriously miss. Thank you.